Now you'll learn about surfaces in Civil 3D, what they are, how they are built, and where and why they are used. You'll learn about the importance of break lines in a surface. We'll show you the differences between triangulation surfaces and grid surfaces. You'll learn about surface styles, labels and tables, and we'll show you how volume surfaces can be used to calculate earthworks cut and fill. Surfaces are used in Civil 3D to create a 3D representation of the ground. They are made up of triangles or grids which are formed by joining up 3D points or adding 3D lines, such as polylines or feature lines. A typical project will require a model of existing conditions. We generally create an existing ground surface from topographical survey information, so we have a model in 3D we can base our design upon. Whilst we use surfaces to represent our original ground, we also create surfaces for designed ground forms such as ponds, building pads, car parks and road surfaces. Grading groups in Civil 3D provide criteria-based grading design that creates surfaces automatically. We also use surfaces directly for designing on. In this example, we're creating a surface profile to display in a profile view. The profile is dynamically linked to the ground surface and will update if either the route of the road or the surface elevations have changed. Once we have a profile view drawn in the model to display the profile, we can lay out the proposed vertical design for the road, using the surface profile to guide our design. A tin surface is made up of triangles and can be created using different types of data. TIN stands for Triangular Irregular Network. Points and contours often provide the primary data used to create surfaces, with break lines used to control the formation of the triangulation. Break lines are ground features such as the top or bottom of an embankment, edges of roads, ditches and so on, and will reorganize the triangles in the surface so that the triangle sides are aligned with the break line, providing a more accurate surface representation. A grid surface is created by importing DEM files or digital elevation model files, which are typically a grid of heights scanned from an aircraft, sometimes called LiDAR data. This type of data is widely and often freely available, and is useful to provide us with large areas of surface where conventional topographical survey would be too costly or difficult. The DEM file contains a regular grid of elevations, and large surfaces can be generated very quickly. They are considered to be a type of raster data like an image, with each pixel being an elevation. These large surface files can be used in our models to provide context for our design, and are useful for creating visualizations of our projects. We can create surfaces from our designed road corridors. These are tin surfaces that are linked to the corridor, and they are built by adding links and feature lines from our assemblies and the corridor model that uses them. When a corridor is edited, the surface will update automatically. We will often create a top surface for our road to show contours of the finished road surface and for visualization. We can also create a formation or datum surface from our corridor that shows the depth of construction for the road, and we can use this to calculate earthworks cut and fill. The display of a surface is controlled by its style. Surface styles can be applied to view surface contours with different intervals, for example. The style controls which components of the surface, points, triangles, contours, elevations or slopes, are displayed, and they can be set independently for viewing in plan or in 3D. We can also use styles to analyze a surface. In this example, we are analyzing the surface by height range. The surface style allows us to understand information about the surface without direct interrogation. Legend tables provide further information about our surfaces. Like most other Civil 3D objects, we can add annotations to our surfaces using different label styles. Elevation labels provide height information at important locations and are useful when we are producing our construction documentation. Contour labels can be added across a surface so that we can interpret the surface contours quickly. All of these labels are dynamic and will update if our design surfaces change. This is important as it means we can produce documentation earlier in the project lifecycle and we don't have to worry about out-of-date information. The format of our labels can be swapped easily. These slope labels are being added either as a slope of 1 in x or as a percentage gradient on flatter slopes. A special type of surface, called a volume surface, is used to compare two surfaces together to calculate volumes of earthworks cut and fill. Unlike a normal tin surface, a volume surface is built from depths, not elevations. These values are derived by subtracting a base surface from a comparison surface. Individual volume surfaces can be combined to give a complete site volume. We can use volume surfaces from different design objects to balance the whole site cut and fill. Volume surfaces contain the information about their depths and volumes. This information can be used to produce a surface analysis of the cut and fill, or isopachite as they are sometimes called. Here we're using a surface style that can be analysed to produce red and green depth bands representing the areas of either cut or fill. Adding a legend table can provide the empirical information we need to make sense of the surface display. This type of information can be invaluable for construction planning. Now that you have seen how you can build surfaces in Civil 3D and how they can be used, you are ready to explore the options for creating your own existing and designed surfaces.